Okay, hi. Another exercise, okay, here. So an electron in a nitrogen atom is excited from the ground state to n equal 4 state. Comment on the correctness of the following statements. True or false? Okay. Question A. Question A, n equal 4 is the first excited state. Okay. So that will be false. Okay. Why? Okay, we have here the nucleus, right? So this is the ground state, n equal 1, okay, n equal 2, n equal 3, n equal 4, and n equal 5, okay? So of course, if the first orbit is the ground state, the first excited state will be n equal 2. The second excited state, n equal 3. The third excited state will be n equal 4. And that's it, continues, okay? So the first excited state will be n equal 2. So the answer is false. B, it takes more energy to ionize or remove the electrons from n equal 4 than from gray state. For the ground state. Okay. No, that is false too. Why? Okay. I will show you, I will share my screen with you. Let me see. I will open the animation here. Okay, give me a moment. Yeah, there it is. Okay, remember. Okay, this is the hydrogen atom. Okay, and this right now, in this moment, that little black ball is the electron that the hydrogen atom has. At this moment, it's in the ground state. Okay, and if you look, these buttons over here, yellow, orange, red, they say the amount of energy that we are going to add to this electron. And if I want to jump to the next level, n equal 2, the yellow button will be the chosen one. Okay, so if I want to jump to the second level, I will need to add 10.19 electron volts. Look at this. Okay, now I am n equal 2. And if I want to jump to the third level, only I have to add 1.89 electron volts. If I want to go to the n equal 4, I will need only 0.66 electron volts. Electron volts, the electron volt is another unit for energy. And if I want to go to the last level, 0.31 electron volt, I will need, and look at this, if I aggregate 0.98 electron volts, I form an ionized atom. Okay, now the atom is ionized. Oh, if I go up a number of levels, less energy I will aggregate to the electron to jump from one level to another. Okay. Yeah, of course, if I aggregate 13.98 electron volts, I will ionize the hydrogen atom uh, from just one heat of energy, right? Okay, but that is very important and answered the question. The addition of energy is going down if I go up on the number of levels that the electron is jumping. Okay. Okay. Less energy I will aggregate if I go from n equal 4 to n equal 5 than, for example, going from level number 1 to level number 2. Okay. Perfect. Okay. So the answer will be false. Okay. C, the electron is farther, farther from the nucleus on average in n equal 4 than in the ground state. Okay, and that will be false. Let me see. No, true. Yeah, it's true because the ground state n equal 1, the electron is closer to the nucleus than uh, the n equal 4 state. Okay, and that is a point on the Bohr's model. Okay, so the ground state here, there is a distance, but on 4, level number 4 or n equal 4, the distance is bigger. Okay, so that will be true. Question D, the wavelength of light emitted when the electron drops from n equal 4 to n equal 1 is longer than the from n equal 4 to n equal 2. Okay, let me see. Okay, if you remember, the speed of light is wavelength by frequency, right? If I clear frequency, the speed of light dividing by the wavelength, that will be frequency. Okay. Energy of a photon is going to be the Planck's constant by the frequency. If I substitute this formula over here on the frequency and the energy, energy is going to be the Planck's constant by the light speed, or the speed of light, sorry, dividing by the wavelength. Okay, so this is the formula of the energy of a photon expressed on its frequency, and this formula is going to be the energy expressed on the wavelength of the light. Frequency, light. These two formulas are the same. Okay. Okay. Only that the first one is frequency. The frequency is present, and then the second one is the wavelength. Okay. So back to the question. Okay, the wavelength of light emitted when the electron drops from n equal 4 to n equal 1 is longer than n equal 4 to n equal 2. Okay, the answer will be false. Okay, why? Okay, let me see. The answer is false, because if you are on level 4 here, okay, the electron is here, and it drops to level 1, okay. Yeah, of course, I know that if the electron goes from a higher level to a lower level, okay, a photon is emitted, okay, and the energy of this photon emitted will be this formula over here, or this one, remember, are the same. Okay, so if you go from level 4 to level 2, okay, okay, the jump here is smaller than the first one, right? But also a photon will be emitted too, okay? And yeah, of course, the formula of this photon will be this one over here, and also this one over here, okay? We'll have the same formula. Okay, but the energy that was emitted from the higher jump will be the higher energy between these two photons over here, okay? Will be the highest of these two photons over here. The energy of the orange photon will be higher than the energy of the green one. Okay, so that means that energy is inversely proportional to wavelength. The meaning of this is that if you increase energy, you will decrease wavelength. That is inversely proportional. If you increase wavelength, the energy will decrease. Ah, okay. So from this relationship, it is obvious that energy is inversely proportional to wavelength. So the energy difference between n equal 4 and n equal 1 is higher. The electron emits the light of a lower wavelength when it drops from n equal 4 to n equal 1. Okay, so this energy is gonna be higher than this energy over here, and if you increase energy, the wavelength is gonna be decreased. Okay, that is inversely proportional. So if you increase energy, the wavelength is gonna be down. If you decrease energy, you will increase your wavelength. Okay, so yeah, of course, it's false, the question. It's false, okay? The wavelength of light emitted when electron drops from n equal 4 to n equal 1 is longer. No, it's false. And E, question E, the wavelength the atom absorbs in going from n equal 1 to n equal 4 is the same as the emitted as it goes from n equal 4 to n equal 1. Yeah, that is true. Okay. Yeah, we're talking about energies conservation, right? So if you go from level number 1 to level number 4, will be the same energy. We got to, it's the same energy that we need to go from level 4 to level 1. Okay. The energy difference between the two levels is the same. So it absorbs or emits same amount of energy when the electrons go up or down, and the wavelengths are also the same. So last question is true. And that's it.